Hello all, welcome back to CyberCrit. Today in this video, we are going to see how we can run any large language model out there locally into our system and create any kind of project just locally without paying a single penny for any LLMs out there. So we will be setting up the large language models locally. We will be also seeing how we can do the vectorization locally, so we don't actually need to go and pay OpenAI or any other third-party models to vectorize our data, and even the result is going to be much more better than even the GPT embedding itself. So please stick towards the end and we are going to see all of these things. So firstly, we'll be seeing how to just simply run a local LLM inside our Python code, and then we'll be seeing how we can integrate it with the Retrieval Augmented Generation, which is RAG, and we will be using the Redis as a vector database, which means our vector database is also going to be locally set up into our system. So each and everything is going to be locally set up. So with that said, if you are interested to build something that is unique and awesome, please make sure to watch the video till the very end. So let's get started. So in order to run any large language models locally, the first step that you need to do is to basically download Ollama. So Ollama is nothing but a kind of tool or software that enables us to download models easily, as well as embedding models too. So it is just one click and wonderful software that will let us use the code, and also the LangChain library that we will be using have great support for this. So as I am on macOS, I will simply click on download macOS. If you are in Linux, you can select Linux. If you are in Windows, you can select Windows, and using the command, you can install it. So once the Ollama installation is complete, the next step is to basically download any models out there. So if you will be thinking which model should I try, there is this models page. And here it contains the library of all different large language models that are getting released hourly, 10 hourly, daily, things like that, and it gets updated here. So here Wizard Llama, which is basically updated just 13 hours ago, Mixtral that is updated 10 minutes ago. So there are this type of models that we will be downloading. And in order to download it, what we actually need to do, we need to select the model. And here I will be telling very important step. Here you will be seeing this parameter, which is 7 billion parameter. So which means if you have a decent CPU and GPU, you will be able to run a 7 billion parameter model easily. So let us suppose you have 8 gigs of RAM or 16 gigs of RAM, you will be easily able to run 7 billion parameter, but that won't run super fast. The speed is going to be limited by your system capability and its requirements. So you can try this type of models. Do not basically jump ahead and go to the models which are 47 billion parameters, because you will not be able to run it on your system. It requires high-end GPU to run it, and I hope most of you that are seeing the video don't have that. And also, if you have very limited CPU, you can also search for the model name PHI, which is basically the model that is 2.7 billion parameters. So it is very small in size, which is approximately 3 billion, and it is made by Microsoft. So you can basically use this too. But here in this particular video, I'll be using Code Gamma. So here you see Code Gamma. So what you can do in order to use it, you can simply say Ollama run Code Gamma, and this is going to simply run this particular model. So if I just copy it, let me open up my terminal. And if I try to paste this, so for me, as I already have downloaded this model, that will simply start running that particular model, and I will be able to chat with it directly. So let's see. So here you are going to see it is going to take some time. And also my RAM usage is already 89%. And here I can ask any coding questions. Python code for prime numbers or things like that. So it is basically trained mostly on programming, but you can also ask different questions too that we will be testing. So here you see it is able to generate things locally into our system. So let me just cut it out. To exit, let me just zoom it a bit. So in order to exit, you just need to write /exit and it will exit. And in order to make it keep running, so you can say Ollama pull. So if you are going to use this command, this is going to download the model, which is approximately 5 gigs in size, and it happened so quickly because I already have downloaded it. So for you, it is going to take some time in order to download it. And once it's downloaded, now we can basically move ahead and go to code. So here is my coding editor, and let's try to start importing with some modules. So here is the first module that I have imported, that is LangChain communities. So here, firstly, make sure that you install this library, pip install LangChain community. But I will be providing you the code, and in that code, you would have this requirements.txt. You can basically first create a virtual environment and then install these requirements. So we can basically be on the same page with the same version, and these things are going to be working exactly same. So with this imported, let's go ahead and try to basically use our local model. So in order to use, we have already used this command and tested it's working. Now we will be basically initializing our LLMs. So we are writing LLM, Ollama, and the name of the model. So here we have pulled out code gamma or gamma. So here we have written its name. So let's suppose you were using some other models. Like let's suppose you went to the website and you are basically trying to use Mixtral. So you have to copy this name, the Mixtral, and then just this name, and then paste it instead of the name of the code gamma, and then you will be able to use different models. So that is the only change that is required. So everything is going to be same, just the name of the model is going to be different. And also kindly make sure that you have already written the command Ollama pull whatever model that you will be willing to use. In suppose Mixtral, so you can write Ollama pull Mixtral, and then you can basically code. And now what we can do, we can simply say with this text the same thing that we did. So Python code for finding prime numbers from 1 to 100, and we are writing llm.invoke text. So here we are trying to invoke the large language models like we do for any other libraries out there, even for ChatGPT model, even for Mixtral that we are using online, even for llama. So any model that we do, we use the same. And that's the beauty of using the LangChain because it is a framework, so it wraps up everything inside it and then provides us a simple user interface so that we can easily plug and play with a different model. So if you are using some other model, you can just simply come here, remove this import and remove this LLM model and replace with your ChatGPT or things like that. So now if I run the code python llm.py, so here also it is going to take time, and here we are not streaming the output. So if we are not streaming the output, which means once the output is generated, then and only then the output is basically going to be produced here. So let's wait. So here if you see it have basically given the code, Python code in the comment, and like is prime number. I will be not be going to be checking this code or the accuracy because that's a thing for other video. We are just trying to see how we can use the local models. And let me also turn off my Wi-Fi. So let me just turn off my Wi-Fi and try to run the code. And here you see there is no Wi-Fi, there is no internet, and let's try to give it a run. So here you see with no Wi-Fi also, it's working because we are working locally. So let's keep the Wi-Fi outside, but you should be on the network because the next thing that we will be doing is basically we vectorizing our data. So let me show you how. So let me just comment this code because we will be testing the vectorization part. So here I am basically using Ollama embedding. So in order to vectorize our data, so vectorization, what it actually means is that we are going to take the text, convert it into the form of numericals, and then store it so that we can basically use it to query our data. So now let's see how we can do that. So just in the same way we have initialized the model for LLMs using Ollama, we have to do the same using Ollama embeddings. So let's try to do that. So here we are saying embeddings is equal to Ollama embeddings, and then we are basically saying this model, the model name is basically nomic embed text. So we also have to basically use the same Ollama command to basically pull this model, and then and only then we will be able to use it because we have to have the model into our system, into our local system, so that we can basically do that. So for that you can go ahead, turn on your Wi-Fi, and then we can basically say something like Ollama pull nomic embedded text. So let me just zoom it a bit. So here you can see I am writing Ollama pull. So as I already have downloaded this too, so this is going to be pretty quick for me, but for you it is going to take some time because it will be downloading this model that embeds, and this is one of the best model that even outperforms the GPT default OpenAI embedding models. So it is much better and it's free, and you can basically host it somewhere if you want to, or you can basically use it in local system, and the size is just 274 megabytes. So once it's done, now let's try to come to the code and let's try to test if it is basically trying to vectorize the data or not, if it is generating the vectors or not. So let's try it out. So now let me just put this code here, and here I have basically written this text. So text is, this is a test document, and this all code is from the documentation of Ollama embeddings. If you try to search, let me search, copy the name so that you can basically see how we basically do search. So Ollama embeddings, if I search, so here is the documentation of the Ollama, and everything related to the Ollama you can easily see here, related to embeddings, related to how we can basically use any models out there. So here you are seeing from LangChain community, we are importing Llama, and here is the sample text and the things, even the text I have, which I have copied from here. So now let's try to run this code and see if it is working or not. So here I am basically running the code, and here you can see this is the vector form, which means the text. So here it took this text, and here we have created the embeddings object. So from embeddings.embed text, which means kindly embed this text into the form of vectors. So and store the result into the query result. And from those vectors, we are just displaying the 5 columns because we don't need to see the entirely large vector that we are going to use. So now let's also comment this code. And I think we should actually import some of the important libraries, and let me delete this code. So here what we are going to do, we will be using a CSV file. So CSV file, we are going to see how we can implement a RAG now. So in order to load CSV file, document file, we are basically going to be using this CSV loader to load CSV file. If you want to load a document, you can basically use that. If you want to see the documentation, you can basically search the document loader, LangChain, things like this. And you can basically find the results for different type of PDF loader, CSV loader, and there are various different things. And this recursive character text splitter is to basically recursively split the text so that we don't pass a very large text if it is like 1 million lines in just a single phase. So we need to basically split and make some small chunks of it. So for that, I have basically written this function. This is the load data, where we have to basically provide the path of the CSV file, and then we are basically creating the instance of CSV loader by providing the path of that CSV file. And then from that particular CSV file, we are basically loading the data out. And then we are using this text splitter, which is basically going to be splitting the text in the form of 1000 records. And then we are also doing chunk overlap so that our model actually knows from this line 15 to 20 are same. So they might be one after another. So that is the reason we are basically using this. And then we are splitting the documents and then returning the text from this particular function. So now once we have the text, we basically need to store it into a vector database. So for that, we need Redis. So how you can install Redis as a vector database, that is going to be very, very easy and simple. And we will be installing it locally, and we will be using the Docker. So let me clear the screen and let me zoom it a bit more, because we will be using Docker command. So here is the command that we will be using: docker run -p, which means map this port of map my 6379 with the Docker 6379 and download this Redis stack server latest. So once you click enter, if you don't already have the Docker of Redis, it will download it and then it will start running. In my case, it already have that Docker container, so it's actually started running. And I hope that you actually know how to install Docker, but if you don't, you can just simply Google how to install Docker, and installing Docker is one of the easiest things. So like we did Ollama, it is pretty much same. And then once this Redis is running, we can move ahead and try to use our vector store. So now let me write a function. Let me just explain you the function. So here we will be passing the text. So whatever text that we will be getting after loading the CSV file, we will be passing it. And here we are passing the index. So in Redis, we basically create an index which basically store the vectors. So we have to basically give any name. So let's suppose if the user don't give any name, I am basically using test index. So this will be kind of the default index. And then I am basically printing that I am inside vectorizing data. And once that is done, here I am trying to basically use this. So what this is basically doing, it is trying to load from the existing index. So let's suppose you have vectorized your 50 million pages record of the data, and then you call it again. So you don't want it to be vectorized one after another. Let's suppose you have vectorized 1 million PDF pages, and again you are going to call the function. You have stored it in the Redis vector store, so you don't actually want it to redo the things again. So that is what I'm trying to do here. Firstly, I'm trying to load it from the existing index, and if it finds that hey, this index actually exists, so I will just simply go ahead and then just establish a connection instead of just converting it into the index, into the vector embeddings, and it will load it from here. But if it fails, so here if it runs means it is already loaded from the existing index. But if you are running it for the first time, passing it the PDF file and the index name for the first time, this is going to run. So Redis from documents, it is going to take the text and also take this embedding objects. So embedding object is basically created here, Ollama embeddings, which we are using nomic embed text. And once we are basically going to be using that, we are going to use Redis URL. And here is a .env file. So this is what you need to actually pass. You have to basically create Redis URL and just name it as Redis colon this 127.0.0.1, because that is what it is for the local host, and you don't actually need to give the password if you are running it locally, and also pass the index name. And also here you have to pass document store dot write schema redis schema.yml. And why is it required? Because in the Redis you have to have the schema. So when you will be reloading it from the index, it requires the schema parameter. So we are basically saving it for the first time when we will be running it. So we would have the schema index, and then we can basically simply load it with that particular schema. So once that is done, we will be running this. A document store is equal to vectorized data and Netflix titles.csv. So let me open Netflix title.csv. So this is the particular CSV file. It have the show ID number, movie, so movie name, and various different informations out there. And this is the data that I got from the Kaggle. And you see this data is very large. So the vectorization process is going to take a while. So let's move ahead and let's try to basically get the related documents. So let's suppose I'm basically going to be asking, hey, can you tell me about this movie name called Blood and Water when it's launched, or things like that. So for that, we have to basically get some relevant documents from our vector database. So here what I am doing, here I have basically written a function. So here I return getting data from the relevant documents. And here related document is equal to document store dot similarity search. So whatever question user is going to ask, so we are taking the questions, we are taking this question, and then with this document stored. So here you see the document store have already established connection with our vector database. So it have already the connection. It is performing the similarity search on the question, and how many similar elements I want to find. I just want to find the top three. If you want top 5, top 10, you can basically customize it here. And once I get those 3, I am basically taking just the content from it. So here in the related doc, I am basically getting the page content out of it, because when you are going to be saving the CSV, it will also be saving your metadata and different type of other informations too. But here we are just interested in the document, or in just the information that are already in the CSV file. And then we are joining it. So here we will be getting the list of text of 3, which means we are getting of the 3 sides, and then we are joining it inside the single content, and then we are basically passing the knowledge. So based on the question, we retrieve the related documents, converted into the single string, and then we are basically passing that knowledge. So now let's bind everything together. So here I have written the get answer function. So here it will printing get answer, and here the knowledge get relevant documents. First we will be getting the related documents, whatever the question the user have asked. Then here we are providing it's the knowledge, passing the knowledge plus whatever question the user have asked, and then it's a simple prompt engineering kind of thing. I have written make sure to answer the question asked, no additional detail required. So it should just answer to the point, because the model that you will be downloading is not going to be super smart as compared to other models that are hosted online. And if you have the powerful CPU, you can try 7 billion parameters. They are very good, at least equivalent to GPT 3.5. And here we are writing LLM is equal to Ollama model code gamma. So here also we are going to be using code gamma, and here you see we'll be using code gamma, which is especially made for coding, but you will be seeing that it also is capable to answer other related questions, but it's just that it's specialized in coding. Let's suppose we are programmer. If someone asks something very basic related to medical science, like, hey, I am having cough, which medicine I should take, which we should not recommend, but we can say, hey, go get paracetamol, things like that. But this is like we are not specialized in it, but we have the general knowledge. That is why we will be it will be able to answer some of the basic things that are not actually related to coding, but it will perform better in the coding related task. So here we are initializing our model. Here we are invoking the model with this particular question, which have the knowledge, the question, and the additional prompt engineering, and then we are returning the answer. So let's try to call it get answer. But if I will run, I think I should be getting some imports missing, because there are multiple imports that we haven't done here. Let me do it. So here we will be using the Redis, so we have to also import the Redis, and also here we are basically using os.getenv, so which is inside our .env file. So what we will do, we will also, sorry, not you, we also have to basically load from .env, import os from import and we can simply say load.env, and it will be picking it up, and let's hope everything works fine. So let's clear the screen. Let's try to run it. Okay, let's see if there is any spelling mistake out here. Okay, so here we are writing text, but what we are actually passing here as a text. So that's a silly mistake that we all make sometime. Before moving forward, let's try to see if we let's try to use each and every functions, and let's see if it is working fine or not. So load data, let's try to load the data and see if it is loading the data or not. So what we need to basically pass for loading the data, just the file name. So print load data, and let's see if there is any error. What's the name of the file? Let's simply copy it from here. Let's paste it, and let's try to run the code. So here you see, okay, so let's just comment it out and let's try to run this again. So here you see we are getting the data completely, and also here you see we are getting other data like metadata, which contains the name of the file, the row number, and things like that. So now we have tested the load data is working fine. Now we also need to make sure to basically call the load data here somewhere, or we can basically do one thing. We can copy the name load data, and what we can do before calling this vectorized data, we basically need to pass the text. So load data, the name of the file. So what it is going to return, it is going to return the text. So we basically need to pass this text to the vector data. So vectorized data is simply going to take the text, and also if you need to basically pass the index name, you can pass it. So here the text will be passed, then it will try to load and see if it is already existing in the index. Then it will say yes, very good, you are already existing, so I can simply take it from you. But here for the very first time it will say no, you don't exist. So I have to basically convert you, vectorize you into the vector form, and then save it. So this is how it is going to run. So it is firstly going to take the text, read the CSV file, convert it into a text, then this document store is basically going to vectorize those data and then return the document store. And here we will be using this inside. When the get answer will be called, it will try to get the related document. So it will be, this function will be called, it will use this document store and it will get the relevant information, then it will just convert it into the single string, and then this knowledge will be passed here with this particular question. And now let's try to see if it is working or not. So let's run. Let me just first activate my environment, Python llm.py. Let's see if it's run. So it's vectorizing data, and remember this CSV file is pretty large. It's 1 megabyte in size and it has 30,000 or more record. So it is going to take lot of time because you are going to run it on your local system. So it might take 1 to 2 minutes or even 5 to 10 minutes depending upon your system requirement. If you have faster system, it can even happen in 30 seconds. So now you can see it's finally getting answer, and it's 11:46. So 11:46 it is able to get the related documents now, and it says blood water was launched in September 24, 2021. Let's see. The question was when the blood and water was launched. So if you go and see blood and water, the launch date, is it here? Wherever. Yeah, September 24, 2021. So it is able to answer this question. So this is how you can basically create the rag. So it took from 39 to 47 minutes because it have basically saved the entire CSV file into the form of vector database. But now if you run the model, if it already have saved, so what it is going to do, it is instead of going to vectorize entire CSV file, which is basically done in this part of the code, it is simply going to be loading from the existing index. So let's try to run this again and see how long it is going to take. So here this time you see vectorized data, it is going to get the document and it is getting the related documents. So it is now converting our question into the form of vectors, then performing the vector search into our Redis vector database, and here is the answer, September 24, 2021. So it took just 13 seconds now. So that's the difference. Previously it took around 7 minutes and now it took 13 seconds. So yes, that's why I written this function in such a way that once it's loaded, we don't need to actually save again and again. So, and also if you need to switch it with any other LLMs out there, just one single change that you need to do, if you need to basically use it with GPT, Llama 2, any other, you can just come here, import those particular libraries, and then just remove, basically change this, and then llm.invoke is going to work exactly same. So yes, this was the video for the today, and please make sure to like this video, subscribe to this channel if you have enjoyed this, and thanks for watching. I'll meet you in the next one.